Hi guys, let me introduce myself. My name is Immanuel Veron Silitonga from State University of Medan. And here I want to explain about my research in my project video. So stay tuned and enjoy my video.
The world is facing the problem of fossil fuels, which contribute to global warming due to increasing emission of gas into the atmosphere. This is not surprising, considering humanity depends on fossil fuels. Therefore, people are trying to find ways to break free from this reliance on non-renewable fossil fuels and transition towards cleaner energy source. One promising alternative energy source is biomass. Biomass is generally described as organic waste produced from various human consumption or production process, such as agricultural residues, energy crops, industrial production residues, livestock, liquid waste, and municipal waste. Indonesia, as a country with one of the highest levels of consumerism, can generate a large amount of biomass waste annually. This indicates a potential for Indonesia to become an energy-independent nation if it can utilize this situation effectively. One unique characteristic of biomass is its high carbon content. Biomass that is converted into carbon formed through thermal decomposition has good thermal stability and high calorific value. This refers to biobriquettes. However, to produce high-quality biobriquettes, especially in terms of calorific value, the raw biomass material must be carefully considered before further processing. One of the promising biomass materials in Indonesia is durian peel waste. Durian peel contains a high proportion of cellulose and lignin, specifically around 50 to 60% cellulose, 5% lignin, and a low starch content. This indicates that the material could be used as an additive in processed food ingredients and other useful products. In addition, durian peel waste has long fiber cells and relatively thick fiber walls, which allows it to bind well when combined with synthetic or mineral adhesive. Due to its high cellulose and lignin content, durian peel is highly suitable as a raw material for briquette production. Furthermore, durian, known as the king of fruits, is highly popular among the Indonesian population. This correlates directly with the large quantity of durian peel waste produced. Biobriquettes made from durian peel waste hold significant environmental and economic potential. From an environmental perspective, the production of biobriquettes does not contribute to increased carbon oxide gas emission. This is because the carbon gas released are not newly introduced compound into the atmosphere, but rather carbon that was initially used to support the biological function of the plant. The carbon emission released are eventually reused by other plants to support their biological process. From an economic perspective, biobriquettes provide added value that can increase community income, especially within communities involved in durian cultivation. The production process of biobriquettes involves 4 steps: the conversion of durian peel into biochar, adhesive preparation, the mixing process of the charcoal with the adhesive, and the molding process of the biobriquettes. In the conventional method, durian peel is converted through direct heating in the presence of oxygen. This method has a drawback: a portion of the carbon is converted into carbon oxide gas, which reduces the carbon content in the resulting biochar. A lower carbon content results in biobriquette with poor thermal stability and low calorific value. Using the pyrolysis methods, however, the resulting biochar contains a higher carbon content because this method decomposes the durian peel at very high temperatures without involving oxygen. Initially, the durian peel is cut into small pieces and washed to remove impurities. After that, it is dried in an oven at 150 degrees Celsius. The dried sample is then placed into the pyrolysis reactor. Next, the pyrolysis device components are assembled, such as installing the condenser, setting the reactor temperature, preparing the nitrogen gas cylinder. The reactor is inserted into the furnace and all components are connected to begin the pyrolysis. Inert nitrogen gas is flowed into the reactor to maintain an oxygen-free environment. The pyrolysis process is carried out at a temperature of 500 degrees Celsius for 2 hours. The adhesive used in the production of biobriquettes in the study consists of wood glue and paper pulp. The preparation process is relatively simple. The wood glue and partially dewatered paper pulp are prepared in advance. The mixing process involves combining the biochar with adhesive in varying mass ratios 1:0.5, 1:0.75, 1:1, and 1:1.25. This mixture is stirred until evenly combined. The amount of durian peel charcoal used is 25 grams. After mixing, the biobriquettes are molded according to a predetermined shape. This process is repeated for each variation. Several tests were conducted, including calorific value tests, moisture content tests, ash content tests, volatile matter content tests. The calorific values can be observed in the following graph. From the data, it is evident that the amount of adhesive significantly affects the calorific value of the test briquettes. The higher the adhesive ratio, the higher the calorific value obtained. The highest calorific value was recorded with wood glue at a 1:1.25 durian peel to adhesive ratio, reaching 4.251 cal per gram. The lowest value was found in the paper pulp adhesive at a 1:0.5 ratio, yielding 3.419 cal per gram. Comparing the two adhesives, wood glue consistently produced better results than paper pulp. However, the calorific values still fall short of coal briquettes, which typically have a calorific value of 6 cal per gram. Moisture content results are shown in the following graph. Among the two types of adhesive test ratios 1:0.5 and 1:1.25, the highest moisture content was observed in wood glue at a 1:1.25 ratio with 2.6%, while the lowest moisture content was also found in the wood glue at a 1:0.5 ratio with 1.64%. The ash content can be observed in the following graph. The highest ash content was recorded in the paper pulp adhesive at a 1:0.5 ratio with 40.69%, while the lowest ash content was recorded in the wood glue adhesive at a 1:1.25 ratio with 20.79%. A high ash content in a biobriquette indicates lower quality, which is inversely proportional to the calorific value. From the graph, it can be concluded the lowest volatile matter content was found in the paper pulp adhesive at a 1:0.5 ratio, which was 33.42%, while the highest volatile matter content was found in the wood glue adhesive at a 1:1.25 ratio, which was 55.98%.